Hi everyone, today we're going to be doing lesson 4. I have to keep track of how many videos I've actually said hi everyone, but today we're going to be doing lesson 4, and you actually know how to do everything in today's lesson, which you can see in the aim. It says I can simplify each side of the equation by combining like terms and then isolating the variable. We've already simplified by combining like terms in the expressions unit, and we've already learned how to isolate the variable in lessons 1, 2, and 3 with 1 and 2 step equations. So hopefully today's lesson will be nice and easy for you. So, whoa, just drew all over the screen there. Scroll up here. Okay, so what are some important things to remember when we are combining like terms? You must have the same variable and exponent in order to combine them, and make sure you include the sign. So when we draw our shapes as shown below, you want to make sure when you circle and square, you take the sign that's in front of the number. And just as a quick review, can we combine 2D and 8D? The answer would be yes, because they have the same letter or same variable. Same variable. And then can we combine 2 and 8D? The answer would be no, because the 8 has a variable of D and the 2 is a constant. So why? Not like terms. So again, as shown below, you have your circles and your squares showing you how to combine like terms like we did in the last unit. So when there are like terms on the same side of the equation, you must combine first. So take a look at example number 1. We have 3x plus 4x equals 49. You want to look at the left-hand side of that equal sign and ask yourself, is there anything that I can simplify, anything I can combine to make this problem easier? I have like terms. I have a 3x and a 4x, and again, notice that I'm circling the term with the sign that's in front of it so I can pay attention to whether I need to add or subtract. So 3x plus 4x added together give me a 7x, both are positive, and equals the 49 on the opposite side. Now what I've just made is a one-step equation. 7 times x equals 49. The opposite of multiplying x by 7 is to divide by 7. So we're using our inverse operations to get rid of the coefficient and get x by itself and isolate it. 49 divided by 7, I now know in order for this equation to be true, x would have to be equal to 7. So if we actually checked this, which again I encourage you to do even if it doesn't say to, that means I would plug 7 in for everywhere you see an x. So instead of 3x plus 4x, it would be 3 times 7 plus 4 times 7. And then you can enter that right into the calculator since it doesn't say to check, and make sure when you hit equals it comes out to be 49. So I'm just going to do it by hand quickly. So 3 times 7 is 21, 4 times 7 is 28, and when I add those together I do in fact get 49. So again, you could just punch that right in, hit equals, and make sure it equals that 49 when you're done. So you are at an advantage in this unit because you can check your answers even if it doesn't say to. Problem number 2, same thing. I'm going to look at the left-hand side of that equal sign. I have a 9x and an x, which has a coefficient of 1. So 9 plus 1x, or 9x plus 1x, I should say, is 10x when combined together, equals 60. This is 10 times x, so in order to isolate the variable, I need to do the inverse or opposite, which is to divide by 10. Whatever you do to the left side, you have to do to the right side. These 10s cancel and reduce to 1, so I now have x is equal to 6. And again, you can substitute that 6 in and check. Make sure when you hit equals, it comes out to be the 60. Number 3, combine like terms on the left-hand side. I have a 6x minus 3x. Signs are different, I subtract, or just do 6 minus 3 in the calculator. And that would give you a 3x equals 18. The opposite of multiplying by 3 is to divide both sides by 3. That eliminates those 3's. X is now isolated. 18 divided by 3 is 6. Number 4, combine like terms on that left-hand side of the equal sign. 4x plus 1x gives you 5x equals 25. Isolate the x by dividing by 5 because that's the opposite of multiplying by 5. X equals 5. And notice that we're dealing with all positives when dividing today. So we won't be putting in the negatives till tomorrow, I believe. keeping it nice and simple. Number 5, again, look at that left-hand side of the equal sign. You want to combine like terms. I have an 8x minus 3x, which gives me a, sorry guys, 5x, distracted, we have landscapers going on, plus 15 comes down, equals 45, because we cannot combine the 15 with the 5x because they are not like terms. One is a constant without a variable. Now what I've created is a two-step equation. So in problems 1 through 4, we had one step. It only took one step to get to the x, to get the x isolated, to get x alone. Now we have to do 2 steps. I have a positive 15 on the left and a 45 on the right, both like terms, but because they're on opposite sides of the equal sign, I have to use opposite operations in order to get those terms together. So the opposite of adding 15 is to subtract 15. Whatever I do to the left side of the equal sign, I do to the right side. 15 take away 15 is 0, which allows me to cross those out. I now have 5x equals 30. Now I'm down to my last step, which is to eliminate the 5. So I'm going to divide by 5. And I have x is equal to 6. And again, you can substitute 6 in for x. Everywhere you see an x on that left-hand side, and when you hit that equal button, it should come out to be 45. Problem number 6. Again, I'm going to look at that left-hand side of the equal sign. There's nothing I can do there. I have a constant and a number with a variable. On the right-hand side, I have 2 constants without variables, so I can combine those together. Negative 5 minus 8, signs the same. I add and keep 8, 9, 10, 11, 12, 13. Or use the calculator. It should be a negative 13. 3x minus 7 equals. Now that I've simplified as much as I could on the left and then simplified as much as I could on the right, now we're going to use our inverse operations. I have a constant of a minus 7 on the left. I'm going to add it to bring it over to my constant of a negative 13 on the right. These now eliminate, become 0. So now I have 3x equals, signs are different, I subtract, I take the sign of the bigger number, or just do negative 13 plus 7 in the calculator. My last step here is to divide to get rid of that 3 in front of the x. X is equal to negative 6 divided by 3 gives me a negative 2 using the tic-tac-toe board, or just typing in negative 6 divided by 3 into your calculator. So I lied. There are negative answers in this lesson today. Number 7, on the left-hand side, there's nothing I can combine together. On the right-hand side, I can combine the 50 and the minus 10. Notice that I'm not combining the 20 with those because it's on the left side. These are on the right side. So 50 minus 10 would give me now a 40 on the right. 4x plus 20 is on the left. In order to get the 20 over to the right-hand side, I would need to subtract it because it's on the opposite side. Opposite operations when they're on opposite sides. 4x equals 20. After I subtract the 20 from both sides, I now divide both sides by 4. I get x is equal to 5. And then the last problem today, we have x over 10 plus 3, which there's nothing I can do on that left-hand side. There's no like terms. I have a 2 minus 4 on the right, and 2 minus 4 is negative 2. So make sure you use your calculator. 2 minus 4. Signs are different. I subtract. I take the sign of the bigger number. I now have x over 10 plus 3 equals that negative 2. Kind of high up there, but it's on the right hand side. In order to get the 3 over to the negative 2, I need to subtract it. It's the opposite of adding. I have x over 10 equals negative 2 minus 3 is a negative 5. Signs are the same. Calculator should be adding them. And now I have x over 10, which means x divided by 10. The opposite of division is multiplication. So I'm going to show multiplication by 10 on both sides to eliminate the division by 10. X now equals negative 5 times 10 is a negative 50 if you use your tic-tac-toe board from Unit 1, or just go right ahead and use that calculator. Okay, so I hope that you found today's lesson easy. If you paid attention in the expressions unit and did well in it, this chapter should not be that bad for you. Make sure you combine those like terms before you start moving terms from left to right or right to left. We'll do the try these in class together. Your Google form starts on page 112.